Section 6.1, the law of sines, part 2 of our notes. The next thing we need to talk about is the ambiguous case. Anytime we're given a side-side angle triangle, we need to be careful because the information that we're given may lead to one possible triangle. It could lead to two possible triangles, or it could lead to no possible triangle at all. So anytime we're given a side-side angle triangle, we need to start by figuring out how many possible triangles there are. So the way that we do this is we find h, the height of the triangle, which we get by doing side b times sine of angle a. If little a is greater than h and a is greater than b, then one triangle is formed. If little a equals h and it's just the right length to form a right triangle, we would get no triangle if little a was less than h. And if little a is greater than h and little a is less than b, then we get two triangles. Example 3, we have a side-side angle triangle. So the first thing we're going to need to do is find h and compare it to side a. So here's my triangle drawn out. Again, I always put C on the top, A on the left, B on the right. It's good to get in a habit like that. And now we're going to find h. So we see that side A is less than h, so no triangle exists. So the information that we're given, no possible triangle exists, and that's just our answer. Example 4, again, we're going to solve a side-side angle triangle. So let's start by seeing if we're going to have no triangle, one triangle, or two triangles. So it looks like we're going to have two triangles in this problem. We're going to start out by drawing the triangle with the information given. And we're going to find B first of all. So we're finding angle B here. So notice, like I told you earlier, I always start with my unknown in the top left. So earlier I had my sides on the top. I had little b over sine of b. But now you see I've flipped the equation. I'm always going to put my unknown first and fill in everything from there. Notice that my sine of 35 over 12, that I also flipped that. We couldn't have left that as 12 over sine of 35. They have to be mirrored to the first ratio. So we're going to get sine of b. We're going to move over the 16 by multiplying. And then any time that we're solving for an angle, so in this case we're solving for b, my very last step is going to be to use the sine inverse button. So I'm going to do sine inverse of everything on the right in my calculator. So I get that for the right side, and then sine inverse of that is going to be 50 degrees. Now, let's talk a little bit about why we're going to have two triangles here. Anytime I'm taking sine of certain numbers, I could get the same answer whether that angle was in quadrant 1 or quadrant 2. So think back to your unit circle. If we have sine of an angle in quadrant 1 and the angle that it relates to in quadrant 2, that's going to have the same sine value because on my unit circle, the y value, the y coordinate is the same. So that's why we have two triangles going on here. To finish out this first triangle, the last thing I need to solve for is angle C. And that'll be easy, just 180 minus 35 minus 50. So here's my first triangle. Just now realizing we haven't solved for side C yet, so we need to do that as well. So little c over sine of C equals side A over sine of A. So we get little c is 20.8, and that is going to finish out our first triangle. Okay, now to solve for triangle number 2. In the last part of this problem, we found that angle B was 50 degrees. So again, I told you that since 50 degrees is in quadrant 1, we're going to have the same sine value for that as we have in our for 130 degrees in quadrant 2. That'll have the same sine value. So now we're going to do this triangle again, but instead of using angle B to be 50, we're going to use angle B is 130. Okay, so drawing out our triangle here. We're going to start by solving for angle C. And then find side C. So there's our second triangle fully solved for. Again, both these triangles are part of your answer. Next, we're going to find the area of our triangles using this formula right here. Let's talk about where this formula comes from, because we're used to finding area using the formula 1/2 base times height. In this triangle, my base is side C, little c, and my height is h. Now remember, we just had a formula for h earlier in the notes. So instead of putting h there, I'm going to replace it with b times sine of a, which was our formula for h. So now if I just rearrange these parts right here, we get area equals 1/2 bc sine of a, which is exactly the formula that we're using to find the area. Now, if you don't know side B and side C, maybe instead you know side A and B or side A and C, then you might use one of these two versions of the formula over here. But it's all the same idea. Example 5. Find the area of a triangle having two side lengths of 8 and 12 meters and an angle of 135 degrees. Round to the nearest square meter. So we're going to use our formula here. Plug in our sides and the angle that we know. Stick that in our calculator, and we get 34 meters squared. Example 6 is a word problem. Two fire lookout stations are 13 miles apart, with Station B directly east of Station A. Both stations spot a fire. The bearing of the fire from Station A is north 35 degrees east, and the bearing of the fire from Station B is north 49 degrees west. How far to the nearest tenth of a mile is the fire from Station B? So first of all, anytime we're given a word problem, we should draw our triangles out, just like in the problems before. But this time, you should put pictures with it so that we kind of have an idea of where the stations are and the fire is in your picture. So here we go. I have Station A and Station B that I've drawn down here, noted by A and B, and my fire in the top, you know, the little orange and yellow thing. So my angle right here, 35 degrees, so that's going to be a 55-degree angle for A. Again, for bearings, looking north, and then 35 degrees angled to the east. 35 degrees isn't what I want. That's not in my triangle, so I need to find its complement, which is 55. Same thing for B. The complement of 49 degrees is 41 degrees. And my two stations here are 13 miles apart. Now the problem is asking me to find out how far the fire is from Station B. So what I'm going to end up solving here is side A, little a. Okay, we need to start by finding angle C. And the reason I had to start here was because I didn't know both B's, but I could easily find both C's by finding the angle for C. Now we can solve for little a. Again, don't put anything in your calculator until the very end. So we get a equals 10.7 miles.